How's it going? This is Tony Dubio from Cisco's Cloud and Managed Services Organization. Today I am providing you with a video demo as a continuation with previous videos that covered the ability to instantiate a net new instance into Cisco OpenStack Private Cloud, both using our GUI dashboard as well as CLI command line interface options to take advantage of direct access to the API. In the previous video, we looked at the native OpenStack API to spin up and spawn a brand new virtual machine that we built based on an existing image. Today what we'll do is we'll take a look into AWS EC2 and a command line tool to provision virtual machines in that environment. Hence, we will take the same tool and syntax that we are familiar with in AWS and apply that tool set, that command line tool set, in our Cisco OpenStack Private Cloud environment. Why will we do that? Perhaps the teams have been trained and have familiarity using the AWS command line tools versus their GUI portal, and for an incremental time, while learning the OpenStack native API command line tool, they may feel more comfortable using the tool that they're already familiar with. So that would be an option for them. They can continue to use the AWS compatible tools because in Cisco OpenStack Private Cloud we support the AWS compatible API that would allow for interoperability from a command line perspective, as well as other tools such as Ansible, Puppet, really any configuration management tool that has the ability to communicate using the REST API and leveraging either the native OpenStack API or the compatibility API. Again, it would just be a matter of preference for the syntax, etc. So let's go ahead and get started here. The first thing we need to do is we need our AWS credentials. Opposed to entering them in the command line, it actually makes more sense to update them in a configuration file that we can launch from a batch script, and then that way we only have to sign in once in order to provision the AWS cloud. And again, we would go through a similar login process with credentials in hand for using the Cisco OpenStack Private Cloud. So if we could pause for a second before we go into the command line, I wanted to point out a few tools, that free open source tools that are at your disposal that would provide access to the AWS compatibility API in your OpenStack environment. The first tool here is the Yuka tool, which is actually a subcomponent of Eucalyptus, which is a vendor owned and provided tool set by HP. The Yuka tools is open source and downloadable and provides a command line tool set that you can use the API compatible syntax in both AWS and in your OpenStack. Hydrofox allows you to leverage your browser, so it's an alternative way of communicating with both AWS and OpenStack is to make REST API calls directly from your browser. And the rest of these tool sets can be downloaded in their particular format, and would also provide you with access to the compatible API in both AWS and leveraging it in OpenStack. And lastly, another alternative is Heat, is the orchestration engine as part of OpenStack, and it provides for continuing to use the cloud formation, the CFN format, which is JSON in this tool set, where natively OpenStack uses YAML syntax, and Heat provides an alternative for continuing to use your CFN format in the OpenStack environment. And in Cisco OpenStack Private Cloud, we would support that as well. The reason why you might use Heat is to initially implement and launch an entire stack of applications based on a template. Once that's up and running, typically then that would transition to lifecycle management types of functions that a command line tool would be very complementary to leveraging your heat as an initial way of providing a complex environment for your application stack, and then leveraging CLI to avoid the dashboard and to make resources readily available to script out and make changes to that application stack environment running in your virtual machine instances in your OpenStack private cloud. Having said all that, let's go ahead and take a look at the Yucca tool as an example of a command line tool leveraging the AWS compatible API in OpenStack private cloud. So the first thing we need to do is we need to log in using that file and launch this batch script that will allow us to authenticate based on our AWS credentials that I've already provided them into this aws.sh file that I'm unable to show you because I do not want to have to change my keys. So that is the contents of that .sh file is my credentials, my actual keys in AWS. So if we source it, it'll run that batch script. Now we're authenticated. So to go ahead and test that out, let's see the available regions that we have in AWS. So that is yucca-describe regions. And what you'll notice, if you're already familiar with either the AWS command line tool or more specifically there's a EC2 API command line tool, either one of them have a similar syntax, and the only difference here is that when you call a parameter, you're prefixing it with Yucca for Yucca tools versus AWS space EC2, or in the case of just the EC2 tool set, then it would just be EC2, and then whatever the parameter like describe regions and so on. You can do a Yucca help and see all of the options that you have available. So we'll go ahead and look at the regions here. So these are the available regions in AWS that we can connect to. The one that we're using is this US East 1 is where I have virtual machines provisioned. And in that batch file, I also note that my preference is to connect to this US East 1 region. The next thing we'll do is we'll take a look at virtual machine instances that are already up and running in my account. So we just change this to instances. Right, and we can see quite a bit of information here. Make it a little bit easier to see. There's information on the VMs themselves. Very verbose information on the instance type we use, region, etc., IP addressing, as well as the private VPC information. Now, if you wanted to paste this into a spreadsheet, then you could add the show empty fields -empty fields. This will add nil fields or columns, so that way it will align properly. You can paste this directly into a spreadsheet and it will look decent. Okay, so the next thing that we want to do is we're going to take a look at a specific instance versus a global view of all the instances that we have within this region. So let me type an instance ID. D8. Okay, so now we are looking at a specific instance. Okay, so some of the other information that is important for us to actually build a virtual machine is we either need to import an image, in this case an AMI image, as it is in AWS EC2, or we can leverage an existing image. So let's go ahead and see what we have available in terms of images. And the one that I'm going to look for is this Web Server Micro, because it's a smaller size of an instance type of a virtual machine. So it'll spin up fairly quickly and not consume too many hardware resources. So I'll take note of this right here, which is the actual image ID. Okay. And then from that, we can take a look at, well, actually that's the minimum that we need. Let's go ahead and spin up a virtual machine. Oh, dash T, okay. Okay, so that should be the parameters that we need to spin up a new virtual machine. Okay, and we can see that it is attaching the volume and bringing up the virtual machine. We can give it a moment here, and then we can check status by going to this specific ID for the instance right here. Okay, so that would be yucca-describe instances. Okay, and we can see here we have IP address information. And let's make this a little bit wider, easier to see. Okay, we can see instead of attaching, it is attached. Okay. So this one is up and running with all of the information that we need to be able to actually connect to it. And we can ping the public IP so that VM is up and running. Okay. Now that we've seen an example of configuring a net new virtual machine in AWS, we can use the AWS compatible API to configure and spawn a new virtual machine instance in our Cisco OpenStack private cloud. In order to do that, we need to log in to our Cisco OpenStack private cloud, and let me explain that a bit in more detail. So to unpack that a bit, let's take a look at these URLs for APIs. The API that we will connect to is this EC2 API. This specific URL maps directly to a port that has been provisioned for this specific project, and this project has been allocated to my account with a quota of hardware resources that are made available to me to be able to launch instances of virtual machines and attach volumes and to perform other lifecycle management tasks in this environment. So I can point my EC2 compatible toolset to this URL, and with the proper credentials I can log in and use a command line versus needing to use this GUI dashboard to configure and provision those virtual machines. So first thing that I would need to do for the native OpenStack command line tool is download this file, this RC file, and then as an alternative I can download this EC2 credentials file to point the AWS compatible API to my OpenStack private cloud, again to provision using that AWS syntax. So I've downloaded these files to my laptop, and what I can do next is I can launch those files, these batch scripts, so that I can log in. So the one that was downloaded for my environment in Cisco OpenStack private cloud for EC2 is this file here, ec2rc.sh. So I'll go ahead and source that file. And then the second one, in case I want to use the OpenStack command line as I did in the previous demo, I would source that file. This one right here. This requires a password. Okay, so now I'm logged into OpenStack and I can use either of the command line tools. So as you recall, we were able to see regions. So let's take a look at that in OpenStack Private Cloud. Okay, in this particular lab environment, I only have a single region that I can connect to, which is this trial 2. And this would be the URL that I need to connect to use the API right here with this 8773. All right. So from that, we can do some of the same tasks that we did in AWS. Let's take a look at that. We can look at the instances. Okay, so these are instances that are running in Cisco OpenStack Private Cloud. Along the same lines as we did in AWS, we can look at a specific instance. So this one should be in here. Okay, so that's a specific instance that is running in my project that represented a Puppet agent from another demo that I provided a few weeks ago. Okay, and then along the same lines in AWS, we need an image. So we were either going to import a brand new image, or we can take advantage of an existing image to use to provision our virtual machine. So let's look at what we got available. Oh, I'm sorry. All right. Okay. We will leverage this particular image right here that represents the Puppet agent image that I used in a previous demo. Having found the proper image, we can now implement the command to provision and spawn a new instance in our Cisco OpenStack Private Cloud using AWS syntax. So let's walk through this command here. So the eku run instances, AMI 00000A1 is the image that we decided to use. -N1 means that we will implement a single virtual machine. We could have multiple, we could ask for multiple virtual machines. -T M1.small is the actual instance type, the size of the virtual machine from a CPU, memory, and storage perspective. And then -K would be the actual key that we can use for SSH after the virtual machine is up and running. So we'll go ahead and launch this. Okay, and as we can see that we have a reservation and it's pending, so we'll go ahead and check the status of this instance. Let's grab its ID. And check the status. You can see that it is up and running. So there you go. We have spun up a virtual machine in AWS and Cisco OpenStack Private Cloud using the exact same syntax from an AWS API compatible toolset. multiple open source options out there to use to have a common tool set to configure based on the AWS syntax. And then again, we have looked at in the previous demonstration the ability to use the native OpenStack API in Cisco OpenStack Private Cloud, which would include commands such as this, like nova list, and we'll find our virtual machine in there as well. All right, so we can list out our virtual machines. We didn't specify the name of the virtual machine, so we can see that Cisco OpenStack Private Cloud just selected an arbitrary name, based off of its default naming. But we could have added that at the end of the command. We could have named the virtual machine whatever we wanted to name the virtual machine. Thank you, and I look forward to seeing you on the next demonstration.